Alright, so we want to do the integral first, so I probably will do oops, can't do that. Start with let u equal to the power, which is x to the half, the power of the exponential, because then du will equal half x to the minus a half dx, which is the same as 1 on 2 square root of x dx. And you can see I have almost got that. If that was a 2 there, which means I put a 2 out the front because that's a 2 times a half, because that 2 I'm putting in at the bottom there is a half. I have now got the dx on 2 root x, which is all, I'm doing green, all that bit. So that bit can become du. So on top we've got, so I've got a 2 at the front, and I've got a du, and then I've got e to the u. Now the limits were, no, I can't see them, they were delta to 1. So if we sub that in, they were the x limits, and now I want the u limits, so I need to sub them into here. So it's the square root of the original ones. So square root of 1 is 1 still, square root of, well, that's just the square root of delta. Alright, so let's go ahead and integrate e to the u, which we know is nice and easy. So e to the u will be 2e to the u. And I'm going between that square root and 1. So when I sub 1 in, I get e to the 1. When I sub square root of delta in, I get square root of delta. Alright, so that would be our answer. And then we're interested to see, so if I make that is the integral, right? That is what the integral equals. So as this goes towards 0 from the right, so positives, we know then that e to the, this, alright, so it's getting smaller and smaller and smaller up here, so it's going towards 0, and e to the 0 is 1, so that's going towards 1. So if we put that in back into our integral, and I'll just put therefore my integral is going towards, so this bit is going towards 1, so I'm going to get 2 lots of e minus 1s.